Hello, everyone. Welcome to our homework help for this week. So let's go ahead and take a look what we've got. We are in chapter 15. That is the project analysis chapter, one of my favorite ones because it really kind of relates to some things that you do in real world. Because that's what you're going to be asked to do is put analysis on projects. All right, well, let's take a look what we have this week on the looking at our textbook here. We have got a couple of three questions. We have our one question, which is 15.1, and that has to do again with risk analysis. Describe the three types of project risk and which type of risk is easiest to measure. And remember on 15.1, that is a question, not a problem, and you're just doing A, B, and C. That appears to be very straightforward, coming right out of the text. Again, most of where you need kind of maybe some hints and guidance are with our problems. Those are the math-oriented stuff. And this week we have 15.5 where we're doing all, and 15.8 where we're doing A, B, C, D, and E. So let's take a look at those. I think the best thing to do, as always, is to go to our Magic Blackboard. I will kind of help you set some of these problems up in looking at them. Should be, I think, pretty straightforward, but I'll give you some guidance on how to tackle these. 15.8 is a little bit more difficult. That is kind of the more of the summation question of everything in the chapter. So, but again, this should all be pretty doable for you as long as you have watched the video lectures as well. So make sure before you even go into homework help that I'm going to give you right now, make sure one, you've read the textbook. Two, you've watched any lectures that I have out for the week. Then three, then come in and watch the homework help. And hopefully with those three components, you should be getting through the homework without a lot of difficulties. So, and that's my hope, that you kind of have a good understanding of the material. All right, well, let's go ahead and take a look, jump to the Magic Blackboard and work through some of these problems. All right, well, let's take a look at the first one, 15.5, and trying a little bit different colors here today on our homework help. 15.5. What we're looking at this one is we are comparing two different projects. We got an X project and a Y project. All of these are involving cash outflows. So that's your kind of your other clue here. You got years. Again, this is all listed, but you got one. I should say one or zero. Sorry, zero. And then we have our 1, 2, and 3 years. And then for each one of these systems, basically you're comparing two different things. In this case, it looks like we are doing computer systems, but it could be anything. The cash outflow is given. Again, these are in thousands. That's all listed within the text. So there's your initial cash outflow, and then various cash outflows for each one of the years. All cash outflows, okay? And your job is to pick. Basically, the first one is assume the initial systems both have average risk, okay? So that's that's a code word. That code word for average risk means your corporate cost of capital. It's given to you in the problem, and that's 10%. Okay? So that's your discount rate. That's what you're going to use. How are you going to solve this? Well, you could do the old hand method on discounting each cash flow back down to zero. Okay, sorry, back down to zero. Okay? Because you're really looking at, this is a glorified net present value question. That's all this is. So you're going to use your net present value calculator, the one that we've been doing for the past couple of modules. Use that calculator. Remember, the trick with that calculator is it does have a couple of areas of input. It has initial investment, okay, and then it has cash flows. As many as you want. You can delete, add, do all kinds of things with the cash flow inputs and all the subsequent areas. The initial investment
just as part of that website, it assumes that's a negative already because it's an investment, okay? So you don't need to put in a negative. So there's the trick. You don't need to put in a negative for this initial investment because it already knows it's a negative. So don't mess up with the sign. Just leave it as a positive initial investment. Try not to overthink it. Initial investment is $500,000. You plug that in. Initial investment is, that's actually would be $1 million. Okay? And you plug that right into there. Okay? Leave the sign positive. For all of the rest of the cash outflows, okay, you're going to put in the negative, all right? Because sometimes, for other decisions, there are other ways you might use this net present value calculator. You might have some negatives and you might have some positives. So that's what's nice about it. Depending on whatever the situation is, you can actually do negatives and positives. So, but in that part, you do have to make sure you're telling the application that those are actually negative cash outflows. So make sure you have the signs correct. Easy peasy. All you do is hit calculate. You're going to get a net present value for each one of these, which will be a negative number, right? And that would be expected. And then you're going to choose which is the lowest, right? Which is the lowest, and that would be, which system should you choose. Then the second part of this problem on 15.5 is that risk adjustment. Okay, remember we talked about that? And this particular problem, you're given a risk adjustment factor of plus minus 2%. Remember how to work that? Again, pretty easy. You're going to apply that to your cost of capital. Now the question for you is, do you use 12 or do you use 8? I'll leave that for you to decide, okay? But remember, and I talk about it specifically in the lecture, but remember, if the project is deemed to have higher risk, okay, it's become more risky. Okay, risk hasn't increased, all right? Risk is bad, right? What would you expect net present value to do? All right, is net present value going to get, worse, or is it going to get better? So, I think intuitively you would say, geez, things are going to go even worse, right? Than the net present values that you calculated initially with this 10% up here, okay? So if you calculate a number and it's bigger, if it's more, in this case, not as bad because it's probably should be negative no matter what. If it's less negative than what you calculated up here, you're probably heading in the wrong direction, okay? Because things are going to get, you're risk adjusting for something in this particular question, you're risk adjusting for more risk, okay? So, I say estimated time on this particular homework assignment is probably 10 minutes. Because once you fill out the net present value calculator, you're just simply changing like 2 numbers, okay? Pretty easy stuff. I think you should get that one done in 10 minutes. Again, show all your inputs. That's all you need to do. Show your inputs so you can get credit for that assignment. All right, let's take a look at probably the more difficult one. That is 15.8. Okay, for 15.8, again, you should find the lecture pretty beneficial for that because I'm pretty much doing a very similar walkthrough on tearing apart this type of a question. But 15.8 is really all about scenario analysis. Okay, it's your classic scenario analysis question. And I'm not going to write all this down, but you got that chart. Okay, you got the chart with the years. You got probabilities. I'm just going to kind of abbreviate here. 2, 5. Yeah, we got 3 probabilities there. Okay, you got years. You got 0, 1, 2, 3, 4, 5. And then you got your initial investments. Okay, 75,000. Remember, the brackets mean negative, which makes sense, your initial upfront. And then you have some various positive cash flows. Again, be careful on your signs, because you're going to use that net present value calculator is going to be your friend for the homework assignment for both questions. So make sure you got that net present value. And you've got the final cash outflows. Might be assuming a little bit of salvage value at the end of this thing, or whatever these particular projects are. Don't remember exactly what what is it. It doesn't really say what we're doing as far as what kind of project it is. But anyhow, you've got this particular single project with these probabilities assigned to the possible outcome. The first question is, what is the project's expected NPV? So I would do this. I'd put another column here, expected NPV, okay? And what you're going to want to do is to calculate the expected values for each one of the years, okay? Let's see, 1, 2, 3, 4, 5, okay? And you're going to want to list those here. And I'll give you a little refresher on how to calculate those. The first one is easy. Year 0 is easy. It's easy because I'm looking at it, and all of the cash flows are the same. Even though the probabilities are the difference, because it's all probabilities added together equal what? 1. You can do the math on this if you want. It'll come out the same way. But that expected expected value, I should say, not net present value, that expected value for year 0 is easy. It's 75,000. Okay, that's a negative, okay, or a parentheses. Now let's see, I miswrote these because that's actually that's going to be, looks like 20,000, double check here. Yeah, it's 20. And for that particular event was 30. Okay. Well, why does that make a difference, Chris, that you just messed up on writing that chart? Because I can't do my little trick up here. I actually have to do the math. So I'll kind of set you up for year 1, and then you're on your own for the rest of the years. So year 1 is simply the probability of that, outcome, whatever it is. Maybe it's the economy or who knows what, number of patients, reimbursement rates, whatever. It was determined that in 25% of the case or probability in the future, this particular event is going to happen. Okay, that's 25%. So all you do is the 0.25 times, in this case, I believe that's 15,000. Oh, I put parentheses in there. Just you could put a multiplication time. Same. But 0.25 times 20 or times 15,000 plus our next one, right, which is 50% chance of making 20,000. I'll do it this way, probably make you guys feel better. okay? Plus, seeing the pattern here? We have another 0.25 times, let's see, 30,000. Okay? So just do your multiplication, add them up, and you're going to get your answer. Okay? That answer would then go right here as your expected value year 1. You're going to do that expected value year 2, year 3, year 4, year 5. Then after you have all these numbers in here, okay, various numbers, dollar amounts, okay, what does that look like? Net present value, right? Because the ultimate, we've got to get net present value. You're going to plug these into your net present value calculator. You got your initial investment. We talked about sign changes, okay? It's a 75,000 cash out, so you don't need to put a negative. You just put the 75,000 into the investment because the application knows that it's an investment. It's a cash out already. If you were to make a mistake and you put a negative in there, it would actually flip it to a positive, so you don't want to do that. But I think I beat that concept pretty heavily already so far. So, and then you want to put in this case, I think they're all going to work out to be positive cash flows, so you just put in your numbers in the cash flows, and I think you have 5 of them, so the application website already defaults to 5 little spots. And then you just hit calculate, and that's it. And then you're going to get your expected net present value for something that we call case or base case, okay? Not best case, base case. And that will mean something here in just a few more minutes. All right, so there's how to do kind of A. B, I'm going to give you a little hint with B. The question is, what are the projects most likely, comma, worst case, comma, and best case NPVs? Well, there's your, you know you're doing NPV, going to have your NPV calculator handy. This one's pretty easy. So you look at, what is the best case scenario here? Well, you can see that this particular one yields you the, you got the most cash flows coming through. The cash flows on this are, again, the highest. So obviously this is going to be your best case, okay? That's best. And then you got your most probable, or you might hear the words most likely, okay? That's going to be this one. You can read my words right up here. And this is the worst case, situation. Will be right up here. Okay, worst case. All you're going to do is you're going to, and I'd do it on a grid, I think it's easier. You're just going to get net present values. A little bit of entry, but we're talking maybe 5 minutes to do that particular part of it, because you're just going to have to enter in all these cash flows and hit calculate to get your net present values for each one of these scenarios. That's all there is to it. Now, the one thing I did, it just also in the it says it in the problem, so you guys wouldn't miss this. But the corporate cost of capital for this particular problem is given, and that's 12%. Okay, so that is given to you. Right, now let's see. We've got what is the project's NPV on the basis of scenario analysis. Okay, so in question A, we had what is the project's expected net present value assuming average risk. Again, when we hear that, that just means your normal cost of capital, not risk adjusted. And then it has parentheses, base case, okay? This is kind of 2 ways to skin the cat. Sorry for all you cat lovers out there, but it's going to come up with the same answer. The same answer that you came up with in A, okay, for that expected net present value is going to be the same. Okay, so whatever that was, net present value is going to be the same. How you could calculate it, you used all of these net present values down here that you've calculated. You could try it and make sure that you have the answers for both. Might be a good way to check yourself. And what you want to do is take these net present values and then multiply them times the probability of those net present values actually happening. So when you calculated these net present values just a few moments ago, you didn't include really the probability of the event. Okay, you looked at each event in isolation to come up with its net present value. So all you would need to do is 25 times whatever you got here, the net present value, I'll call it worst case, plus 50% probability times net present value most likely plus 0.25 times net present value, and that's what we're calling best case. Add those all together and you get your answer. That answer should equal the same answer you got in A. Okay? All right, that one wasn't too bad. The next one is going to be standard deviation. This will be relatively simple, but you're going to get big numbers, like, millions, okay? Definitely do this one on pencil and, with pencil and paper. Listen to the lecture. I mean, it's very easy to, to set up. And go back to, again, the lecture where I talk about setting up the variance first. You got to calculate the variance. That's the hard part. Once you get variance and you're going to get your answer, then boop, you're just going to hit the square root button and then you'll come up with your standard deviation. Again, a little plug and chug, but not too terribly difficult. And the other key is that you are going to be using the, you're going to want to use the, whatever you've got, down here for these net present values for each one of these individual cases. You're going to want to use those, okay? I won't give you all the hints, but you're going to be using these numbers that you already calculated, which you calculated in question B, and you're going to be using that number that you used for in question A, okay, where you got the NPV for the project, okay. You're going to be using both of these in your formula. So you're going to be setting that up. You're going to be doing a little bit of subtraction. Be careful about your signs. In that case, you're going to be square rooting, a little bit of cubing, and then on parts of it, and then you're going to use a square root. So again, look at the lecture. It'll guide you through that. It's not very difficult. Again, I estimate that one would probably take you 5 minutes in total to do that. And then lastly, we're going to have a question E, and that's going to be risk adjustment. So you're going to be taking that cost of capital and you're going to be adjusting the risk. In this particular case, it looks like the risk adjustment factor is plus minus 2%. The question is, what do you use? Are you using 14 or are you going to be using 10%? Okay. If the risk of the project is going up, just keep in mind things are going to look worse. So you can actually calculate both. It's not that difficult because you're going to have a lot, your inputs are already going to be in there. You're in your web page, most likely from one of the last problems that you've done, and you're just going to be changing that corporate cost of capital. Okay, so it should not be, again, changing a couple numbers, hitting calculate is pretty much all you'll need to do. And then you're going to ask yourself, is the project still financially attractive? I will give you a little bit of hint, I guess, on the discount rate to use for that adjusted cost of capital, I guess, to help you a little bit out with that. When we were doing the other problem, the 15.5, the interest rate that we adjusted corporate cost of capital actually down, okay? And this one you will want to, I'll help you out, you're going to want to adjust it up, okay? But just for heck of it, make sure, try it, see what the 10 and see what happens. But you're going to want to make your net present value, again, your net present value after you have increased the risk, okay, should be less than what you calculated, right over here. All right, should be less. And you could play with each one of these numbers. Literally takes you a minute, and you can figure out which one shrinks that net present value. So if you forget which way to adjust it, you can always do that. All right, that concludes the homework help for this week. Good luck with the assignments. Again, I don't think it's going to take, probably, the first one might take a half an hour where you're actually writing and typing. With the math problems, I guess with 15.5 really should take you about 5 minutes. And I would say 15.8, again, might take about another 30 minutes to an hour. So I think you're looking at maybe about 2.5 hours total maximum time for the homework this week. All right, that concludes homework help. Hope you found this beneficial.